Alright, so the problem is, consider a child flying a kite on the beach, and the child's mother standing at an unknown distance from the child. The child lets the kite at 100 feet, so the string's 100 feet long. If the kite is being blown at a constant wind in the direction of the child, such that the kite continuously floats at an angle of 75 degrees in the direction of the wind. If the mom's view of the kite yields a 35-degree angle, how far is the mother from her child? Alright, so this point will be the child, and this point will be the mom. So the mom sees 35 degrees, child sees 75 degrees, and the kite is 100, because this is the kite right here. So we want to solve for distance d here. And in order to do that, I think the best way to go about it is using the law of sines. We can first know, since this is going to be a straight line, that this has to add up to 180, so it's going to be 105. Using the triangle sum 180 theorem, we know that this is 140. It has to add up to 180, so this is 40 degrees. So the law of sines would say that d over sine of 40 degrees is equal to 100 over sine of 35 degrees. We could simplify that as d equals 100 sine 40 over sine 35, and 100 sine 40 over sine 35 is equal to 112.0665, and it's in feet, so feet. Alright, for the next part. The child was trying to keep the rope exactly 100 feet, but the child was distracted and the rope went an unknown amount further beyond 100 feet. The child notices the rope being pulled and further and stops the rope. Due to the constant wind, the rope still floats at an angle of elevation of 75 degrees with respect to the child. However, from the mother's perspective, her angle of elevation has changed to 45 degrees. Assuming the mother has not changed position from part A, determine the new length of the string between the child and the kite. Alright. So, what do we know still? We know that this is 112.0665, that this is 75 degrees, that this is 45 degrees. Alright. So, again, we'd solve for this, which is 105. Use the 180 triangle sum, which would make this 30 degrees. And then we would do law of sines again to solve for length. So we have 112.0665 over sine of 30 degrees equals length over sine of 45 degrees. Alright? And then we could say that length equals sine 45 degrees times 112.0665 over sine of 30 degrees, which means that length equals 158.486. That's the new total length, and the new length added on would then be 58.486. Also, on this, it would be 45 and 30. And this part's still right. I just said the wrong numbers. Alright?